Thank you, and thanks everybody for joining us this morning. We do know which secretary?
Homeland Security.
Secretary of Homeland Security we're up against. He's talking about AI. I suggested to him that his talk should be our surrender plan for when the machines take over, but apparently the United States federal government didn't agree with my choices and recommendations on their content. Welcome to CloudSec 0 to Hero, or Hero to Zero. And this is going to be a little bit of a different talk. So the background of this is Chris and I are friends. We've been both of us doing this cloud work for over a decade, getting involved early. And I have this side hobby of doing stuff like that. So I'm a disaster response paramedic. And we were talking about what are some of the problems that we've encountered in organizations where either he has worked full time or where I have gone in in an advisory capacity, and very consistently, we go in and something is a mess, and you've just got to figure out where do you start and how do you clean up. And this is a really common thing that a lot of our friends who do this work also experience. And we came up with the concept of, of using some of my background in disaster response and emergency medicine and as a paramedic, and applying that to this problem, because it's the same thing. If I'm sitting there on an ambulance or going into a disaster, we have a definition of a mass casualty incident. And sometimes it's like this. This is a picture I took when I had responded to Hurricane Katrina. But the reality is if I show up on a car wreck and there's 2 patients, that meets the definition of a mass casualty incident, because there are more patients than we have available resources. And this is a large part of the problem that we face in cloud security, because a lot of you have been put into situations where you walk in the door and the organization has built out a lot of stuff, and then you've got to figure out where the problems are because dev has been running around. I don't blame them. This isn't they're bad people thing. It's they're doing their job and now you have to do your job. Well, in the disaster world, we have a lot of protocols and procedures to handle these things. Because a mass casualty incident isn't like what you guys see on CNN all the time. It's I don't know, I'd have one once a week on a shift when I was still working this stuff full time. And this is an example. This is called simple triage and rapid treatment of if I walk in and I have hundreds of patients, and personally I have dealt with situations where I've had hundreds of patients, how can I quickly triage, prioritize, and manage that incident? And so I'm not going to talk much about the non-technical stuff. This is a cloud security talk. And when Chris and I got together and started talking through this, we're going to use that as a framing mechanism to talk about the techniques that we have used when we go into organizations and actually deal with these.
Yep. So, our scenario is you wake up one day and congratulations, CISO has hired you to be a cloud security architect, and this is your new cloud environment. And that's you. So day one, what do? Again, first cloud security hire, things have been happening for 15 years, finished their cloud migration 6 months ago, and CISO hired you to make it all better. So basically, now what do?
Just out of curiosity, how many people have been in a situation kind of like this where you just end up in a mess? Yeah.
How many of you are still in that situation?
Oh. So the idea is, and what I learned through all of these years of the other stuff that I've done, is that you can have systems for taming chaos. You can have systematic approaches for dealing with these very complex, highly variable problems. Whatever somebody throws at you, you just learn to deal with it. And that's part of your job, is you don't get to call 911 when you're 911. And you just have to deal with what's in front of your face. This is an example of one of those. This one is Advanced Medical Life Support. It's one of the certifications that I've had for a bunch of the years. And the idea behind it is, let's take some of those lessons and apply them to security. So we came up with this framing mechanism, which is, all right, how do I do this when I'm that cloud sec? I've just been airdropped into some organization that's been mismanaged for the last decade, is in 3 different cloud providers, and we have thousands of findings in our CSPM. And we're going to walk through this where and through all of these various phases as part of this, because I do think that, you know what, this is not a new problem anymore. Most of you, based on your hand raising, have dealt with this. We have both dealt with this in multiple organizations many times over. So let's just, you know, have a systemic way of dealing with it.
I'd be happy if I only had 1,000 findings in my CSPM. I can stand up a new AWS org and have 1,000 findings in my CSPM.
That's just because it's you standing up the org.
Well, perhaps. So if we take this and apply it to cloud security, you know, basically simple triage and rapid, we'll call it remediation. And that works as an acronym. You know, basically the same 4 categories. Minor issues that are regulatory, hard to exploit, delayed, they're important, but they're typically a secondary risk factor, something that would happen after an initial access. Immediate, these are the ones that you really, really want to jump on right away, and I call them the big gaping security holes. They're easy to fix, usually, and when resolved, you really get a good security bang for your buck. And then in START, there's this term expectant, which is, I'll let you define it.
Will be soon approaching room temperature.
Yeah. And so in this model, those are things that, you know, in START, you know, they don't get immediate treatment. In this model, these are the ones that basically are important. You will need to solve them, but you could spend a lot of effort trying to resolve this, remediate it, save the patient's life with minimal benefit, and there's more things that you can fix in that time frame.
The concept here is that the rules change when you are overwhelmed, when you've got so much that you're facing. And so, for example, a patient that I would spend an hour trying to save, we spend no time on, because we have ones that we know we can save versus the ones that are either already gone or we can't do anything with. And that is really the same thing in your organizations, because you're going to find problems with your cloud security stuff, and we're going to go through specifically what those are. We're not just going to talk in these generalities, that the effort to fix it, you will be leaving all of these many thousands of things open to focus on like these 10 things. And you got to fix the 1,000 before the 10.
Yep. So step 1 is, you know, orient yourself in this new environment. And for me, that always starts with inventory. What cloud accounts do I have? Hell, what cloud providers do I have? Who's responsible for them? Finding the ownership, finding a directly accountable individual, finding a technical contact who can explain why something is the way it is critical. And we say do this in your first week. Well, finding the owners definitely takes longer than that. Deploy a CSPM, any CSPM. Download something off the internet, get something free. You're not really building a program right now. You're really just trying to understand the lay of the land. How many patients do you have? And then identify your telemetry. You know, what kind of audit logging, what kind of access logging do you have? Because, you know, at some point you're going to need to, you know, determine if you have a breach, and you'll need to have that logging. So the accounts and owners, again, that comes down to CIS critical controls, right? Have a hardware inventory, have a software inventory, somewhere in between there in the new world, have a cloud inventory. And then again, owners, who can make a decision about the account, and who can answer technical questions about it. And I think the executive sponsor concept, who can make a decision about the application in the account, is critical. Because sometimes it's like, okay, if we do this, something might break. Somebody has to be able to like either accept the risk or say, okay, no, we can't accept this risk. We have to take an operational impact.
I mean, to this day, I have done assessments where I walk in the door and I find out that the owner of the Amazon root account, or one of the Amazon root accounts, like, is somebody's personal email address and cell phone who no longer works for the organization or was a contractor. I see at least 3 people nodding their heads going, oh yeah, we had that. Which is bad, because that person can like own that entire account and everything in it with a phone call or an email.
Yep. So telemetry, again, getting cloud audit logs, critical. You know, any CSP threat services that may be enabled, like GuardDuty, Defenders, whatever. If you have your IDP logs, Okta, Azure AD.
If you don't have your IDP logs, just ask China.
Yeah.
I mean, for those of you on Okta.
Yeah. Actually, I don't think they care about the logs. They just care about,
Got it.
Yeah. And then that CSPM, again, these are your patients. There's something that is misconfigured, or there are things that shouldn't exist nowadays, like IAM users in AWS. And again, this isn't something that requires fancy attack path methodology. Any simple open source thing can give you a list of your problems, and that's what you're looking for at this point, is just a list.
Chris's entire goal for years, so that we've been friends and trying to talk about presenting, was just to have a talk about pissing or pooping on CSPM. See, I moderated my language there. And yet he's telling everybody you do need one, so that says a lot.
Yes, I mean, you do need a CSPM. You don't need a fancy CSPM. You don't need a fancy CSPM at this stage in the triage process, because you want to start with the big gaping security holes, and that doesn't require, a 6-figure, 7-figure CSPM contract. That requires Prowler or Security Hub or Scout Suite or something.
We will warn you that the ones from the cloud providers tend to be biased and sometimes less configurable. Like, I use Security Hub for some things. I won't use it too much for this. Chris has spent about a year now doing research trying to make Security Hub work for his needs, and is still kind of like struggling a bit, but there are plenty of free and open source options out there as well.
Actually, I've made Security Hub. I've come to peace with that, so.
Got it.
Yes.
Got it. So you're expectant.
Yes,
Okay.
exactly.
Yeah. Yeah, so the idea with the CSPM and why we emphasize that so much is it's going to tell you your misconfigurations, and you're going to get like huge results. So like the early days, the first assessments I used to do, I would go out and I'd use mostly just Prowler and I'd do a scan, but I wouldn't give that to the client. I would put it all into a spreadsheet, and then I would filter and prioritize and contextualize everything that's in there. That said, I have had to stop work and in organizations either where I've been in an operational role or again where I've been the outsider coming in, because we found something that had to be dealt with right away. And so we used the stop the bleed concept. Some of you had that. The whole concept of stop the bleed came out because we realized we've been teaching so many people CPR that they were checking airways and doing chest compressions where the person was like, every time you push, the blood's squirting out onto the floor, and that's not conducive. Sorry, I mean, hopefully that's not going over the top, but that's not conducive to future life. You have to stop the immediate problems right away, and we have these. So as you're going through, as you're information gathering, as you're running your scanners, because you're going to have to run this across these different environments, you're always looking for the oh my God moments. Let me give you a specific example. I did one, I was doing work with an organization, I'm going to be super incredibly generic about this, and I was reviewing actually configuration results, and then I was going through they were in Amazon, a GuardDuty result, and we got a finding for brute force attempts against a particular thing. And I go, okay, that shouldn't be happening. The finding was over a month old. It was like 2 or 3 months old at that point. Nobody had looked at it. And then I looked at that individual resource that was exposed to the internet and had not been patched and updated, and nobody knew who patched or updated it or who owned it for that time period. And that is an immediate, I don't wait to write a report. I go and say, you have to fix this and burn this thing down right now because you can't trust it. So you're gonna have those that you're gonna be dealing with at the time. And some of these are going to be more complex problems, so you're going to probably need like an open source tool or something you have to kind of drop in place to deal with it.
Yep. Like
complete lack of telemetry or something along those lines.
Yeah, 3389 on a Windows machine, open to the world.
Yep. So when we wrote this presentation, the description for it, I threw in like a little joke, and I'm like, and we're going to present the universal cloud threat model, because really, you're about to see that almost all cloud threats come down to like 2 or 3 things that you face, the vast majority of stuff. And then Chris is like, well, what is this? We need to write a white paper about it. So we're going to go through the model, but we actually have published a paper that we've linked to at the end, which goes in more detail, because in the time we have for a talk today, we can't get through all of that.
Yep. So again, what is the universal cloud threat model?
Don't present with old people.
Pretty much, yeah. We're all in the same clouds. We all have the same set of problems. We all have the same threat actors going after the same sets of things. So this was basically like, look, we can give this to everybody and give them a place to start building, whether you're a small startup or a large multinational bank. Here's a place to start.
If you think about it, for those who've been around long enough, we talk about the internet background radiation, and that's always been like you post something on the internet, the attackers, the scanner tools are there automatically all the time. So what's different in cloud? Well, in cloud, we are all on the same 3 platforms. If you're on the other 2, you got bigger problems. But we're all on basically the same 3 platforms. And that means that if the attackers in any way, shape, or form through their automation find something like credentials or find something exposed, they run through automated sequences of attacks. And what we are finding, so this is what this research is based on. One is, we read through all the threat reports every vendor puts out. You always have to read those skeptically, but they're all pretty consistent with what we've come up with. 2 is that we have a lot of friends in the cloud security community, including friends at the vendors. And we talk with them all the time. What are you seeing? What are you experiencing? So this isn't quantitative, it is qualitative. But we feel pretty darn certain that what we're about to show is going to match up with the experiences of what your risks are. Because they're going after whatever's in the cloud, and they don't care if you're Bank of America or Bank of Billy Bob's Bait Shop. They're going to start with the same thing because they don't know who you are yet. They just know what they found and that it's something in cloud because it's been masked that way.
Yeah.
So the idea is, we call this the 90-90. This is the threat model for 90% of the attacks that 90% of organizations will experience. This is not meant to be a substitute for MITRE. This is not meant to get away from your application threat modeling or your data flow diagrams. But if you are operating on a major public cloud provider, this is exactly what you will see all day, every day.
Yep. And so basically the threat model comes down to a reasonably simple statement. Threat actors have objectives against targets using attack vectors that we as defenders observe as attack sequences. And really this is almost like Mad Libs at this point, or even a game of Clue. It's Midnight Blizzard in the test tenant with the self-enrollment user. So if we start with threat actors, we've got pretty much what you would expect, what we're talking about here at RSA. State Nexus threat actors, cyber criminals and cyber syndicates, hacktivists, insider threats, script kiddies, security researchers who are the polo shirt wearing versions of the script kiddie hoodie wearers, 80s style hackers.
And my cat, he's a total a-hole. Just cannot be trusted.
He sabotaged this research paper a couple times.
Yeah, for real.
Yeah. And the objectives, are basically what we expect. Financial gain from crypto mining or spam, or ransomware of various flavors.
What did Kelly Shortridge? How did she word it in her tweet?
I don't remember.
It all comes down to money crimes.
Yeah, pretty much.
Yeah. Read the whole Verizon DBIR and go, oh, it's money crimes.
It's money crimes, yeah. Or denial of service attacks. Again, that's sort of the hacktivist threat actor. Industrial or nation state espionage. But again, 90% of us don't have anything that any other country really cares about. But these are some of the objectives that fit in that model.
So go back for 1 second. Under these objectives, what matters, what's different for cloud here, they are going to use these incredibly elastic, expansive cloud resources for their financial gain. And if you look at all the threat reports and everything else, the vast majority of what people are experiencing right now in cloud is crypto mining and ransomware and a bit of spam. There is everything else in there as well, but that is the majority of what organizations are experiencing for their cloud native attacks that are out there. We're going to go through the sequences and show you how these happen. That's what this threat model is about. It's not just, oh, we're going to scare you with threat actors and with what they want to do. We're going to tell you how they do it, and that's going to help you prioritize your security goals and do your triage.
And really, you can kind of see the uptick of spam as an objective, and if you just look at the price of Bitcoin. When Bitcoin's up, they're crypto mining. When Bitcoin's down, yep, they're trying to send spam.
Yep.
Everything is old is new again. Targets, it's your data, it's your compute resources, which again goes back to crypto mining, network for spam or DDoS attacks. Pipelines and supply chain are just another way to get the credentials that they need to go and hit the other, other pieces of the attack vector.
You guys know, like the XZ attack, they got into spent 2 years building a persona to inject very well disguised malicious code into a common software package. And we found it, or somebody had found it, somebody at Microsoft, ironically. And like, do you think that that has not happened multiple times and those things are already in our org? So that's why supply chain stuff's coming up.
Supply chain is there. So the attack vectors are really where the money hits the road. Yeah, there we go. That's the analogy I'm going to use. Money hits the road. You know, and it's typically credentials, network exposures, misconfigurations, or as I like to say, the cloud is in fact dark and full of terrors. So the first one of these is lost on exposed credentials. This is definitely the number one thing that we see. You put some credentials in GitHub, and next thing you know, somebody is trying to figure out, hey, can I send email with these? You know, can I spin up a crypto miner? Can I go spin up a crypto miner everywhere?
One of my favorite things about giving these presentations on stage is when Chris will throw something like this up and I see certain smiles and head nods. And I'm like, hey, they're nerds.
Yeah.
There are kinds of nerds.
Yes. Which apparently the scene actually never happened in the movie, or in the show. The second one really is, you know, publicly exposed resources. You know, public S3 buckets have plagued us since 2014, 2015. And then really ramped up in a few years later. So
don't forget that Microsoft Blob Storage where they released like tons of like keys and stuff that were accidentally in a public,
Yep. So again, publicly exposed resources specific to the cloud provider like buckets, but there's a whole bunch of other things that can be publicly exposed in this way. And then there's, you know, credentials that come via application security flaws. And so, you know, capital one, unpatched vulnerabilities in 0 days on the internet. So this is, again, you know, multiple examples of these in the last couple months. You know, I talked about 3389 on the internet. You know, you don't want to expose the ransomware deployment protocol onto a public machine because I'm going to get it, I'm going to get the creds, and now I'm going to pivot and move vertically and then laterally across the cloud environment. Supply chain, again, talking about XV. Domain takeovers are an interesting one because of the elastic and shared tenancy nature of the cloud. You can actually have a pointer to something, and then you release that something, and somebody else can come along and grab that something, and now you're pointing to somebody else's resource.
The common is, like, developers will point to an S3 bucket and they'll use a CNAME so that within the app or within the DNS it'll point to that S3 bucket. And then the problem is if they go, oh, I don't need that bucket anymore, they release it. Those names are within Amazon's namespace.
And they're global.
Somebody else can take that name, and it's done with IP addresses as well. Attackers have automated scanners. There was a great talk a few years ago by somebody from Starbucks. This was occurring so much at Starbucks because they have these brands, and it's really good if you can get a Starbucks domain to go ahead and actually use that for spam and phishing attacks, that Starbucks built their own scanner that would automatically scan all of their own DNS and automatically do a subdomain takeover anytime they found a dangling reference. And it was all like scripted out so that they could grab it before the bad guys.
And so this example here is an NPM package called BigNum that was deploying some binary stuff out of an S3 bucket. The developers changed how they were doing it. They didn't change the code path, so it looked for the bucket, didn't see the bucket, it went to somewhere else. Somebody figured that out, created the bucket, and now BigNum was deploying malware. So that's another kind of example of a supply chain attack too, via domain takeover. And then there's the other kinds of threats in the cloud. And so two cozy bears in a midnight blizzard. You know, the cloud provider attacks, there's not much you can do about other than pick your cloud providers
attacks
wisely.
Against your provider, like,
yeah.
Sorry, Azure. But they've been in the news lately. They just got ripped apart because like DoD and government stuff was exposed because the attackers got into Microsoft.
Yep. So CSPOs are one, Gen AI is another one. We haven't really seen a lot of Gen AI attacks. Now, people will try and sell you something to protect you from the Gen AI attacks, but my recommendation is go find a good secret scanner first before you start worrying about, Gen AI.
A lot of our motivation behind doing this talk is Chris and I are both believers in getting rid of the security poverty line, where, and one of the problems that we experience around threats is that all of you probably get the newsletters and you see all the big threats and the high-end research, and that is wonderful work. Like some of our friends do that work. We're not criticizing that, but it is distracting. That is not where most of your real problems are. It's not the latest thing that the Wiz or Orca or anybody else has come up with or independent researchers. It's this really basic stuff. But the problem is this basic stuff, simple doesn't scale. Just because it's a simple problem and we know what it is, doesn't mean it's always easy to deal with it. And so we're gonna walk through the sequences and then give you some suggestions on how to scale out your operations. And so the sequences, we put these together for this is how the attackers operate. It's different than a MITRE attack or the cyber kill chain because we wanted to focus on not a generic sequence of steps, but the exact steps in the exact order that the attackers use for the most common attacks. This is all well documented in the white paper. So if you guys, again, we'll put the link up. It's really easy to find out there and we have more of them. And so like, for example, this one is the crypto mining. How does crypto mining occur? Well, you publicly expose a resource that's vulnerable. So you're gonna hack it, they're gonna install their mining software, they're gonna get going. Number two, they're gonna get your credentials, or in my case, my credentials about 10 years ago, and then they're gonna use those, see what their permissions are in Amazon or in Azure, and then launch virtual machines, instances based on their own images with the crypto miners running in them. Because you can't make money mining crypto if you're paying the electricity bill. And then the third way of doing something like that is if they can get into the supply chain and backdoor images or containers and just get you to run those. And we know there's a lot of certified pre-owned images that are available in public repositories. So pretty straightforward. And the same thing, like manage our credentials, don't have public stuff exposed. This is why we built the model the way we did with the know your vectors, because if you can knock down those vectors, you're gonna disrupt the sequences. And then what was the other one? So this is ransomware. And ransomware was an interesting one because it's not how we thought it was happening. So all of us fancy cloud security researchers are like, all right, well, they're getting into Key Vault or they're getting into KMS and they're encrypting your data because ransomware is about encryption, right? And then our friends from one of the cloud providers, we went to a talk a few years ago, and they're like, well, no, they just get an access key that gives them access to the S3 bucket. They copy all the data out, they delete the data, and then they upload a ransom note.
Actually, half the time, they don't copy out all the data. They just copy out a sample of the data, make you think they copied out all the data, and so then you pay the ransom and they're like, here's 15 of the 15 million records back. Have a nice day, and thank you for the Bitcoin.
What's the origin of that, though? The same vector, exposed credentials.
Yep.
It's like every time. And then I think we had one more in here, lateral movement. And just because there's all these fancy cloud native things, it also doesn't mean the attacker's just not going to try and pop a cloud network, and then navigate around. The only difference is they're constantly looking everywhere to get cloud credentials and escalate.
Yep.
And they're doing that on premise. If they get into your data center now, most of the toolkits, everybody knows Brian Krebs, right? I was talking with him last week. We've known each other for a while. And I was asking him, like he's basically a researcher, do the kits look for, the attack kits, are they looking for cloud tokens? Are they looking for cloud credentials? And they are. They've just automated this.
Yep. And I like to talk about lateral movement, and then there's vertical movement, right? You know, hey, I've got a toehold on an EC2 instance. I grab the credentials. Now I've vertically pivoted from the network plane to the cloud plane. And from there, I can laterally move from one account to another account. And then I can vertically move down by, taking over or modifying a security group or pushing my own key into a VM.
So one of the things we didn't express verbally yet, which is in the paper, is a lot of this is around what we call differentiated versus undifferentiated attacks. And if somebody finds an access key or they find a public resource, they are likely going to start with an undifferentiated attack. That means they don't know who you are, they don't care who you are. They know they're on cloud, and so they have access to resources, vast resources, potentially, and launching because they can launch compute instances or whatever else. So those are the undifferentiated. At some point, they may shift to a differentiated, or they may start there. If you're the large bank or the federal agency, they're going to also be targeting you. And the differentiated it is, well, I found something interesting, so now the human being is going to look. And that's really undifferentiated, highly automated attacks, constantly going background radiation. At some point, the human may realize something is interesting, and then they're going to put more work effort in. But attackers are lazy, and they're financially motivated, other than the nation state side. And for the lazy and financially motivated, well, actually, the North Korea is financially motivated because they're doing all the Bitcoin stuff these days. So they're going to go through the path of least resistance before the other stuff. And so we hope that you understand, let's find the other stuff first, and then we can focus our efforts on stopping the more advanced stuff.
Yeah. So all of this really comes down to, and I said it earlier, big gaping security holes. And these are the ones that you want to hit immediately. Some examples of those are S3 buckets that are publicly listable or writable. Why? Because there's almost no use case for a publicly writable S3 bucket. And there's very rarely a case for a listable one. But if I have a listable public bucket, I can just start sifting through looking for something interesting, something that may not be linked to, something that may be old. Publicly writable, you know, that's how the LA Times ended up hosting crypto mining software and passing it out to everybody who visited their travel site. Root access keys in the AWS accounts, again, super powerful, can't really limit what they do. You want to find those and you want to convert those to users.
Now, those of you on Azure, the problem is so I have to do the Azure stuff because Chris refuses to touch it, and I'm used to dealing with dead bodies. And oh, come on, that wasn't even a little funny. I mean, okay, thank you, I appreciate it. Sorry for the Microsoft people in the room. You guys are having a rough month. But like global admin, so there's like problems on Azure, like you have to use global admin for some stuff, where in Amazon you can mostly never touch root once you set it up, except with a few exceptions.
Yeah, except for the exceptions, which are actually quite a few. Yeah,
so if we should just do a blog post on fighting the global admin fight, because that is a legitimately difficult problem right now.
Yeah. Anything that's missing MFA that a human is doing, because a human's probably going to pick a, summer 2025 password. And I always do summer 2025 as my password so that the hackers won't guess it. So anything that's easily guessable, easily brute forceable is going to be something that a human's possibly going to generate. 3389, again, open to the world. Access keys dating back to the Obama administration, hell, at this point, dating back to the Trump administration, is getting to the point of these should be rotated. They have been out there long enough. They're potentially exposed. Rotate your access keys. The other reason to rotate access keys, because if they do get compromised, you're going to have a fire drill to figure out who is responsible, where these keys are, how do I rotate them. And so if you have a regular rotation, it doesn't need to be 90 days, once a year. Keep track of the access key strings and who you give them to. I'm moving to a place where access keys are a Jira request. And so I have the access key in Jira. I can go search if I need to tell somebody to rotate, or if I need to deal with it in an incident, I've got a record of who I gave it to and where they put it.
And on Azure, watch out for those SAS tokens. That's the one that's biting a lot of people in the butt right now, because they are semi-permanent ways of accessing things. So the next step is, this is the focus around how do I deal with the initial pile of things. And our objective to this point in the talk is to say, all right, let's figure out where our accounts are, let's figure out where our biggest misconfigurations are, and to give you the tools to prioritize those. And if you use the paper, that'll help guide you towards tuning that more for your individual circumstances, a little bit more than we can get to in the talk. Now, and really the goal of this talk, we call this hero to zero, is getting into an operational cycle. So with any large incident, the ones I've been in, there is always a scale-up operation when we're initially flooding areas with resources and blocking and tackling and dealing with the worst problems. But stuff's not fixed right away. And so we have to move into more of operational periods. So this comes from the incident command system. If you've ever gone through, it's actually free training. I do recommend it for people. You can go through because the principles apply. This is known as the planning cycle. You get it in ICS 300. And the concept is that we define an operational period with specific metrics. Metrics should be SMART, specific, measurable, achievable, realistic, and time-based. And then at the end of that operational period, we come together and we recycle. Now, typically, unlike when I go out on disasters, we run with usually a 12 or a 24-hour operational period, depending on what our shift changes are going to be. For us in security and the work that we do, I think of these as sprints. I'm doing a 1 week or a 2 week sprint. And where are my defined objectives over that sprint? And then where do I need to go and who do I need to talk to achieve those defined objectives? And so, again, we've closed the big gaping security holes. We've stopped the bleed. Now we start getting ourselves, and the objective of this is to go from crisis mode and get back to just normal day-to-day operational mode. This is the bridge phase to get between those two.
Yep. So now that you've gotten into business as usual, what tools do you need? So you need to pick your permanent cloud security posture monitoring tool. Now you're starting to actually look at talking to vendors, looking at contracts, everything else. You need to get an inventory tool in place, something that will allow you to capture not just what cloud accounts you have, but okay, what are all the IP addresses in my environment? How do I get those IP addresses to whatever my security operations team is so that if they see an alert about some RFC 1918 address, they can say, okay, it's this VNet in this subscription in this region, and it's a database or it's a NAT gateway or something. Get your logging in place, and then get your cloud security or cloud provider telemetry pieces in place, things like GuardDuty.
And some of you will be in situations where you have a lot of this, but it's scattered. Like you have 3 different ones of these things or those situations. Yeah. You really want to try and unify it.
And you may have it in AWS, you may have GuardDuty in one account in one region. You need it in every account, every region. Basically the window of time when the Capital One attack occurred coincides with the window of time that GuardDuty was not available in Stockholm. Identity federation, so this is how you're going to make sure that your joiners, your movers, your leavers all are handled, that there's no access left over if somebody leaves the organization or no longer needs access. Secret scanning is critical. Get something like secret scanning in place for all your source code repos. And then SBOM, software bill of materials. It's last on the list, but it's really important because someday some random person on the internet is going to compromise a critical compression library that's somehow tied to SSH, and you're going to need to know, okay, is this in my environment? Oops. So we talked about cloud providers. They're not your friends. What you see is not going to be as good as what you'll find on the show floor, but what you find on the show floor here also requires you to go through a procurement cycle, probably get a budget. It's a lot easier to turn on GuardDuty and ask for forgiveness when the bill goes up $10,000 than it is to go and do a third-party risk review and have your lawyers look at contracts and everything else. And then in some cases you have no choice because the cloud provider is the only one with the actual telemetry that you want.
Yeah, it's not that the providers are evil or anything else. It's just when they produce products, they have to have something that they can sustain and sell to everybody on that platform, which is a scale issue. And then point vendors, individual, like half my life is as a vendor, and we don't have to deal with that scale issue. I would love to have that scale issue. Everybody would, but that doesn't happen. So you can actually build a little bit differently. And so this was, Chris wrote down how he decides between buy, build, or download. We're not going to talk through this completely, but the general idea is, and then I made the pretty picture because that's my job here. He comes up with the content, and then I come up with the graphics. The pretty picture concept here is that this is what we find in a lot of organizations. The crux of your decision making around your tool chains are, do you have money or not? And if you don't have a lot of money, and you don't have a lot of experience and you have to do something at scale, buff up your resume because you've been put in a position to fail. If you don't have to scale it, you can probably learn and knock some stuff together. Ideally, you want to be able to buy something if you can, but you'll be buying cheaper. On the other hand, just because you have a lot of budget, maybe you have experience and you want to build and customize it yourself. So it's just kind of a decision tree to kind of get you through the process of, and a lot of the places where we know, like we've got friends at some very large organizations with thousands of like Amazon accounts or Azure subscriptions. They'll typically do a mix. They'll buy some stuff off the shelf and they'll do customization. These are the people with like the near infinite budgets, which very few people have. So even then you're going to build a bit. The challenge is for many of you in your organizations is you're going to have maybe enough budget, but you're going to be really low on time and experience. You're going to have a low budget, and then you're going to just have to rely on your tools. I encourage you to up your skills over that time period because you can't trust any of the tools. You just can't. It's not that they're bad. It's just that there's limits to what tools can do.
And I find that I tend to either buy or download, and then if I have coding time and cycles, it's the integration. It's how do I make the tool present the data in the way that's right for the organization that I'm in right now. Yeah. And that's critical. So whether it's spreadsheets tied to executive sponsors or JIRA tickets that get pushed from the CSPM straight into the queues of the DevOps teams that are responsible for fixing, that really depends on what your organization is, but that's where if you've got some coding talent, resource, and time to focus.
And so then we're going to hit this transitional period, and there's different phases of these planning cycles in the transition. The first is let's get our tooling and ourselves set up. Let's get our program in good shape. Once your program is in good shape, then you can start going out and trying to deal with the politics and working with the teams that are the ones that are building and managing all of these different environments.
So we kind of made the joke of going from pandemic to endemic. So endemic is okay. This is the new normal. There's still bad things in the environment, but we've kind of accepted it and we've kind of got it a little bit under control. So here's where you really want to find your systemic issues. So you have a lot of wide open security groups. That's probably a lack of a VPN, or somehow your builders can't route over RFC 1918. Lots of IAM users tend to be related to identity system problems. Have you federated, identities across multiple Amazon accounts? Do you have public buckets? Is that a user education problem? Is it a lack of them understanding IAM? Do you not have golden modules for how to deploy, S3 bucket securely? So you want to find these things, and these become engineering efforts, right? Okay, we've got a lot of databases that have public IP addresses because we have a lot of independent VPCs. How do we set up some kind of transit gateway? How do we set up something so that when you're in the office, you can ride RFC 1918 IP addresses into the cloud? Or if you're working from home, that your VPN connects into the cloud. So maybe you're not bouncing through your home office in one city to then bounce across the country to another region.
Fix the things that are going to keep creating the same problems for you over and over and get off the hamster wheel.
Yeah. And then don't think you can start with this grand paved road systems. You're not Eisenhower. You're not going to build a glorious interstate system right away. Start by just clearing the roads. Cut down the trees, remove the big boulders. You can move faster if you just have a footpath than if you're, wandering in deep forest.
Paved roads, if you don't know the concept, is like these fully automated ways of getting stuff that's deployed out there so the developers drop into that and they get what they need. And what Chris is saying is that you don't have to have this perfect, pristine, absolutely right, landing zone or whatever the latest term for it is. You get some stuff good enough and you give them paths of least resistance, because attackers are lazy, developers are lazy, humans are lazy. We're all lazy. I am incredibly lazy. So, and we're going to go down the easy way.
Yeah. And then write a baseline. Only then, really, do you want to start focusing on the guardrails themselves. And you want to find the guardrails that are not on the level ground with trees on either side. You want to find them on the mountain roads where when somebody goes off the road, they're going to have something bad happen to them.
Azure policies, service control policies, things that stop people from doing bad things.
Yep.
Automated remediation, that's when you start bringing those things into play.
Yeah, and this is where the guardrails are really, you want to focus those on big gaping security holes. So now you want to extend your threat model, right? You know, maybe you are Bank of America, maybe you are a cryptocurrency company. You know, you probably then have other targets. You may have other threat actors. You may have other attack vectors like phishing. You know, nobody is going to go and phish a college student to get their AWS credentials, but they're definitely going to go phish the senior DevOps engineer at a Fortune 10 bank.
I mean, you look at like the LastPass attack, highly directed, highly focused, going after an individual developer who just happened to have a personal Plex server.
Right, a vulnerable personal Plex server.
Vulnerable personal, like that was the pathway. Those attacks do exist. We are not saying they don't. It's just that most of what you're experiencing is not going to be that, and not all of you will ever experience that.
Yeah. And then think about your unique adversaries and threats. So, you know, I like to joke that I consider auditors part of my threat model. You know, we said regulatory things are kind of that green minor thing when
It's
you're—
not a joke. We wrote it into our threat model.
the green things, the regulatory things are not something that you want to do during your start triage, but you need to address them. You know, the threat model, the auditors need to be part of your threat model. Mergers and acquisitions. So I've dealt with a lot of M&A stuff in my time and was generally reasonably happy to see the CSRB report come out and cite mergers and acquisitions as a contributing factor to the confusion around the Storm 0558 attack.
Microsoft.
Yeah. And then there's these other nation state actors who definitely potentially are an issue for you depending on what regulatory, whether you're publicly traded, et cetera.
You will, we call them threat actors, not because they're trying to steal your money or whatever, but if auditors' job is to come in and to get audit findings dealt with, and regulators' jobs are to come in and get whatever their job is to dealt with, and that may not mean that it's better for your security and your operations on a day-to-day basis. And so you have to temper those outside influences that are going to maybe try to derail you from your program.
Yeah, and your priorities, yeah. And then, you know, we'd be remiss to not talk about least privilege in a cloud security talk. So, you know, at this point, you want to start looking at getting to least privilege. Do you have every developer out there with read-only access to every cloud account? Should they have that? Should they be able to look at all the data, all the secrets? Probably not. So you want to start thinking about how do you go down that quest for least privilege.
And then you want to get into improving your program's maturity. So this is the cloud security maturity model. It's something that, that I wrote for Cloud Security Alliance and for IANS, if you know who those groups are. And the idea is to give a roadmap to, and this is publicly accessible, to give a roadmap to what does the cloud journey look like? And keep in mind, your goal is not to get to the end of that 5. 5 is very expensive and can take a very long time. It is what maturity in which of the cloud security domains makes sense for you. So I did try to make this good. It's got hundreds of key performance indicators. They're cloud security control objectives and control samples to make it more measurable as well. So there's a whole spreadsheet you can download. Just give you a sense of where you are and where you may want to take your program.
Yep. All right, so putting it all together, first of all, don't panic. Or you can panic a little bit, but you know, just remember, you know, what are the 90% of the things that are going to happen to 90% of the organizations? So URL to the white paper for the universal cloud threat model. And then you want to actually use the start to actually prioritize your issues. Only once you've done this do you want to really start implementing guardrails and paved roads. Deal with the big gaping security holes, deal with the immediate things, figure out a plan for your expectant issues, and then start building the guardrails.
Your goal is to operationalize and automate to the best of your ability. We know people who have gotten there. We have a mutual friend who I was out with Sunday night. His organization, his IR team, like really efficient. It's not that they don't have problems. They just always fall within the same general things and they don't tend to have major incidents. and they're well prepared for when they do have those. It's the day-to-day job. It's like, yeah, when you call 911, it's probably the worst day of your life. When I walk in the door, I'm just making a dime. And really probably just a dime. Paramedics are paid horribly.
Yep. Cool. So that's it. URLs and links to resources and how to reach us. And with that, we'll take any questions.
The best thing here, if Chris forgot to put it on, which he did, we are in the Cloud Security Forum. So it's a Slack community that we're both in. It's an open community. You can hit us up. We can get you involved there. Incredibly positive, like, group of people who's always helping other people out. We're also, hit us up anytime. We're on all the various socials and stuff. So we are out of time. If there's one question, we'll hit the one, and then we'll go answer other questions in the hallway.
Forwardcloudsec.org has a link to the Slack channel.
Yep.
Hi, my name is Mustafa. Thank you for the presentation. Question about NIST CSF version 2.0. They came up with the new edition, which is governance and risk.
Yeah.
I didn't see that in the presentation.
It is in the maturity model.
Okay.
I added governance as a top line of the maturity model with samples there. Governance is incredibly important. I once said all cloud security failures are IAM failures, and all IAM failures are governance failures. So when we start talking about the politics and operationalizing, that's exactly what we meant. Anyway, we apologize. We're out of time. We're going to drop our microphones, and you can hit us in the hallway.
Thank you.